All right, let's get started. Hello, all. Welcome to our latest webinar on adopting the DevOps mindset. We have Mili from Bisma, who is the Chief Software Quality Engineer. He's also a Browserstack champion, so I'm really, really excited to have him speak about this very interesting topic today. I hope all of you are staying healthy and staying safe. Thank you for taking the time to join us in this webinar. Before we get started, I will just walk through a couple of housekeeping items. So our webinar will run for 60 minutes today. It is being recorded. I see several of you having asking questions in the chat whether we will be sharing this recording. Yes, we will. We will be making this available to all of you, and we'll also be uploading it on our YouTube channel. So you can, in probably a few days after the webinar is over, you will be able to go to our YouTube channel and see the webinar recording. You can submit questions. We encourage you to submit questions. There is a Q&A button on the Zoom app. So please use that button to submit all of your Q&A. And we will save 15 minutes towards the end of the webinar to answer as many of your questions as possible. So yeah, please feel free to drop in your questions throughout the session. Awesome. So before I get started with the webinar, I wanted to just quickly walk through a little bit about, tell everyone here a little bit about Browserstack. So we have been around for the last 10 years. We recently celebrated our 10-year anniversary in September of last year. And it's a very interesting story how we started. Ritesh and Nakul, our co-founders, started Browserstack because they were trying to solve a problem that they had as developers. They built a website, they wanted to test it, and they could not, for the life of them, figure out how to test it on IE because they were both using Macs when they were building the website. So they realized testing on IE at that point in time, 10 years ago, was a big problem that developers around the world faced, and that led to the inception of Browserstack. And literally, they launched with support for that one browser, we haven't looked back since then. We reached 1,000 customers in about 6 months. We've launched real iOS and real Android devices. We launched testing mobile apps, both manual and automated, a few years ago. And we acquired Percy and launched visual testing on Browserstack a couple of years ago. And recently, we raised our Series B funding of $200 million at a $4 billion valuation. And along the way, we've opened 4 offices, and we're probably close to 1,000 employees now since this slide was last created. So yeah, it's been a very, very interesting and great journey. We've got 50,000 plus customers across all of the key verticals. The who's who of each of these verticals use Browserstack to test their software. We also support thousands of open source projects on Browserstack. So big projects like Angular, Ember, Discourse use Browserstack to test their software. We've achieved a massive amount of scale, right? We have over 4 million registered users. We have users running over 72 billion Selenium commands a year on our platform. We have, as is evident with all of you joining from all over the world, we have 135 countries with customers, and we have 15 globally distributed data centers through which we provide our browsers and devices. The world's largest cloud providers also rely on Browserstack to test their software. And I wanted to just spend 1 minute walking you through the different products that we have today. So on the web testing side, which is basically allowing you to test your websites and web apps, we have Live, which allows you to do interactive testing of your websites. You can literally launch your website on any desktop browser or on a mobile browser on a real mobile device. So we support real iOS and Android devices. You can launch your website on that and run through all your test cases. Automate allows you to test your websites using Selenium and JavaScript. Again, you can run your tests at a massive amount of level of scale. You can run hundreds or even thousands of parallels at a time to optimize your build times across our Selenium grid of browsers and real mobile devices. And Percy allows you to test how your website looks, right? Live and Automate help you test how your website functions in different browsers and devices. Percy allows you to visually review your website, make sure that it's rendering the way you want it to render on different browsers and devices. On the mobile app side, we have App Live, which allows you to manually test your mobile apps on real iOS and Android devices. And we have App Automate, which allows you to run your automated tests written using Appium, Espresso, XUI, again, across a variety of real iOS and Android devices. And we have several free tools which you can check out through our website, screenshots to look at cross-browser compatibility. So you can basically take screenshots of your website on different browsers. Responsive, you can check how your website is being rendered across different browsers and devices. And SpeedLab, which allows you to understand how or benchmark your website on different browsers and devices and understand the performance of your website on different browsers and devices. All right, with that, I'm going to introduce our speaker for tonight, who is Mili. Mili is a technology enthusiast. He's spoken at many conferences and very passionate about software engineering and leadership. I've had the pleasure of working or interacting with him previously as part of the Champions program, and he's got some really, really interesting insights based on many, many years of experience. He works at Visma as a chief software quality engineer, and is part of a team that's helping companies and teams move into the DevOps mindset. Outside of Bisma, he also runs the monthly Norwegian Test Forum, who organize meetups in Norway. He just loves, I think, getting people together who have a passion for testing and DevOps. So thank you all for joining. And Mili, I'm going to stop my share and hand it over to you. While we do that, folks, there's going to be a quick poll that the team is going to pop up on the interface. Just give us a chance to understand your level of where your company, your organization stands in terms of automation maturity, and what are some of the things that you want to focus on in terms of your testing goals. So just take a minute to answer these questions. It will also help us understand what are the kinds of topics you're interested in, and it'll also help Mili sort of tailor his talk according to the audience. So thank you. Over to you, Mili.
Thank you very much and for the kind introduction. And also thank you for giving the opportunity to share what we are doing in Visma. Let me just know if you see sort of the correct screen.
Yep, you can see it.
That's great. Just let me know when I can start, or how long should we wait for the poll?
No, you can get started, Mili.
Okay, sure. Thank you all for joining. I hope that you will be a bit inspired from what we are doing. So the agenda for today is basically to go through what actually led us to change how we used to work and how we are working today. I will also give you some insights into some of the core principles that we are using to drive our software delivery teams. Those are the teams that are basically creating the software and deploying and delivering in Visma. We also have some data and some research that basically backed up our initial gut feelings and assumptions. And then we will also dive into sort of how we are doing continuous testing to support all this and where we are going from here. And as been already mentioned, I encourage you to write your questions along the way. It might be that we answer some of them throughout the presentation, but in case we don't, we will have some time to address them at the end. So let's start with this quote from Peter Diamandis. The world is not just changing fast, it's accelerating. And I think this is basically what highlights some of the needs or something that led us to change as well. We basically today we see a huge amount of changes in the world in general, but especially sort of in our software industry. And we also see sort of that the rate of change is ever increasing. So the changes just keep piling up and up and up. Some examples of this is, for instance, that the cost of computing power has decreased tremendously over the last years. So computing power is basically like 100 times cheaper today than it was 10 years ago. So the price of technology is just going downwards, and it becomes much more easily sort of to start with this, which lead us to that both the technology and the knowledge is increasingly being democratized. And this means that previously, in order to start a software, to start a company, or to start building something, you need to have a lot of people, you need to have a lot of resources and everything else sort of just to start and pay a huge amounts of money upfront. While today, basically everyone from their boys or girls' bedrooms can, by a click of a button, start a number of servers, start different services, and actually create some disruptive apps that can be used by anyone in the world. And while this is true for that we in Visma as well can do this, it's also true for our competitors, but it's also true for criminals. We also know that the sort of cybercrime will basically increase, and we have seen a huge increase only the last few years, I would say. And this is something that is also going to sort of ever increase. So we also need to be prepared for these changes as well going forward. And we also seen that the users or our customers, they basically expect innovation from all companies, myself included. When I'm using some apps or something, I'm expecting everything to work. I sort of have high expectations for everything that is created today. So this means that also, while it is really easy to create something, to get started with something, it's also easy sort of to lose market value or market share if you sort of don't adapt and if you don't change fast. So this leads us to this, basically that disruption is now more likely than ever. So being the technology and knowledge being democratized, industry is evolving, accelerating and changing, and we have more and more competition all around us, while all the customers and users are even more demanding, and now today than ever before have more options. If something doesn't work, you can easily change to someone else and basically use those apps or services. So this led us to back in 2015 to stop a bit and consider what are we actually doing in Visma and how are we actually developing services. So we wanted to basically be able to change quickly. We wanted to be able to experiment more and sort of be ready if we see that we are on the wrong path or a wrong track, basically. So that is sort of what drove our change, what ignited our change. But before I dive into a bit some of the details about that, just let me give you some idea of who Bisma is, basically. And Bisma is a SaaS company. We have the headquarters up here in Oslo, in Norway. It's basically a collection of companies. So it's not sort of one company delivering one service or one product, but we have more than 200 companies within Visma who all are highly autonomous. And there are very few things in Visma that are sort of enforced or mandated throughout all of these different companies. And what we do in Visma is that we try to simplify and automate complex processes. We create some mission critical software and solutions like HRM, payrolls, accounting, financial management, e-government, just to mention a few. And we are basically around 15,000 people today. Very much same as we had before. Like these slides, they change as long as you sort of save them, basically. But this is Visma in sort of a really short nutshell. So what happened previously in Visma is that we basically had this separation of development and testing. We had own test teams. We had own development teams. When something was about to be tested, it was sort of thrown over the wall to the test team. And this created basically a lot of bottlenecks, a lot of slowness in the way that we worked. And there were a lot of handovers and procedures and checkoffs, etc. And then we decided basically to break down this wall because we basically could not see any value in doing it this way in our context. And then it led also to another change that we basically back in 2015, when we were starting discussing this was how we used to operate. We had development teams deliver something. They were owning some environments, usually the test environments closer to development. And then we have an operational team that was basically owning a pre-production and production environment. And this again led to a lot of bottlenecks, a lot of blame games, and it was not a very scalable way of working, especially in Visma that we had a lot of services and teams who were integrating with each other. And that meant that when team A was about to change something, they needed to sort of get their checklist or checkoffs by team B, C, D, E, F, G, etc. And then everyone will sort of converge together, do a lot of testing, deploy in pre-production, production, get back together again. And we realized that this is sort of, we cannot work like this if we are going to be sort of a key player in the market going forwards. So basically what we did is that we broke down these walls and basically created these autonomous teams. This is basically how we work today. And this is sort of how our teams feel and look like today. We are sort of a bunch of superheroes within the different service delivery teams. And the service delivery team is a team that is cross-functional, it's autonomous, they have full and exclusive ownership of what they do and end-to-end responsibility. And they also have the authority to decide what they want and what they need to develop, which tools to use, and basically do whatever pleases them. And this, of course, leads to better decisions because whoever is creating the product or service, they know their market, they know the users, and they know what is best for them, not some centralized governance. So this was the first of 3 core principles that we did. So first one, we changed the way we were organized in order to remove these dependencies, to lighten up the processes, and basically remove everything that was slowing us down. Then the second one is basically continuous delivery. And this allows basically the teams to quickly make changes and quickly experiment. And we invested a lot of practices and a lot of work into basically give the teams abilities to be able to deliver frequently. And if you just see on this example here, like back in 2015, we released approximately like 6 times per year on an average. But then back in 2021, all these teams who are working this way released approximately 21 times per month. So this is a huge change just then in just some years. And this is in average, which means, of course, that there are some teams delivering less than 21 times a month, but there are also some teams that are delivering much more than 21 times a month. And in order to be able to accelerate this, we also took the advantage of the hyperscalers, the public cloud from AWS, Azure, and Google Cloud. So in Bisma, we are basically using all 3 of these, and the teams can choose whatever public cloud vendor they want to use. But this gave us some opportunities that we didn't have before in the old way of working. So we figured out that this is actually the way that we want to develop. We want to have these core principles sort of as a core for how we want to develop. And this gave sort of birth to something that we call the Visma cloud delivery model. And this is sort of the Visma way of developing, delivering, and operating cloud services, which also describes basically like how teams should be organized, how we should work, and also gives some technical requirements to basically be able to deliver these best practices for successful cloud service deliveries. I won't go too much into detail about this way of working, but I also wanted to provide some links here if you want to deep dive into what the Visma cloud delivery model is. So, and you will probably get the slides afterwards as well. So these links will be clickable. But then how can we actually determine that these things that we actually did, were we sort of on the right direction or not? So we did have a sort of a gut feeling that we knew that sort of continuous delivery, DevOps, public cloud, it was sort of the next thing, and we wanted to develop in a modern way and utilize all the modern engineering practices that we knew about. But we also wanted to have some data that sort of backed us up, and not only the gut feeling. So then we also wanted to see, okay, if we were to put all the different teams from Visma in working with this model, how can we easily measure something that can give us some pointers into the right direction? So we started by saying like, yep, of course, we are interested in delivering more changes to production. So, okay, let's start to see how often are we actually deploying changes into production. Then we also wanted to see, okay, we know that if we start to deploy even more than we are doing today, won't that lead to even more sort of incidents? So we definitely want to track that. And we knew that when an incident occurs, and it will occur, how quickly are we able to sort of get back on track? And of course, the availability of our services, which we were basically tracking all together before. And this led to basically that we were looking into and recording automatically all of these metrics. When a team pushes a change to production, we recorded like the one change to production, and also if that change basically failed or not, that was also recorded. And this was automatically recorded for all teams working in this way. Going a bit some years ahead, then in 2018 and 19, basically our hunch or gut feeling was also backed up by some serious research by the Accelerate and the State of the DevOps Reports. For those of you who are perhaps not familiar with this, this is basically a research that took over 6 years, where Forrest Graham, Jim Humble, and Kim, they basically and their teams surveyed around 30,000 people to see how are they actually developing and delivering software, and looked into what kind of metrics or what kind of things they were doing, which were basically an indicators of good software delivery, and can that software delivery be transmitted into some commercial or business goals. And it turns out that these 5 metrics here, the delivery lead time, deployment frequency, change failure rate, time to restore, and availability, could be used to predict basically the organization, whether a team or not are likely to meet or exceed their organizational goals, such as revenue or revenue growth or market share. And luckily for us, we already had 4 of them. So we didn't find a good way to measure the delivery lead time in the beginning, but we had good data on the rest of them. But now, last year and a half, we are also tracking all of these 5 metrics for all teams. And about the same time, McKinsey and the company, they also came up with this developer velocity index, where they have 46 different KPIs or metrics that if you are doing well on these metrics, you will basically also doing sort of software engineering really well. And I will show you sort of what that means as well. And since we had a lot of data, we also did some investigation in both our own data and to see, okay, does this basically make sense for some of these findings as well? Can this be backed up by our own data? And on the right-hand side here, you see sort of the McKinsey and company results. So the top quartile of the teams who were doing really well on this 46 metrics, their revenue growth grew 5 times more than the bottom quartile. And this is some of the similar numbers that we saw when we were measuring sort of the teams that were deploying frequently to production. The top quartile here for us in Visma, they basically grew their customer-based value 4 times than the bottom one. And this is sort of, if you see the graphs, they are quite similar. So we were using this deployment frequency sort of as a proxy for this number. What we also realized was that if you don't measure, you're actually doing even worse than those one that measure. So this is clearly sort of an opportunity for you as well to at least just start measuring, and then sort of you can figure out where you need to be going forward. But why actually do use the deployment frequency basically as a proxy? Because we think that the deployment frequency is basically an indication of how your engineering performance is working or not. And it's much better to get feedback from your customers, your users, and how things are working hundreds of times during a year, rather than, for instance, 5 or 6 times during a year, or even if you do monthly, 12 times during a year. And this also means that the smaller changes that you create, the lower risk there is actually to introduce an error, because when you're focusing on something small, you're only focusing on the change that you are working on right now. You deploy to production, you enable it for the customers, and then basically, if something doesn't work, it's easily tracked back, rather than doing like big bang releases with 500, 600 changes. And then when something doesn't work, it can be time consuming actually to pinpoint it. And the last part, of course, is that these deployment frequency, if you're doing them really quickly, it means also that you are doing them basically with ease. There's a low cost of doing this change. So you are sort of avoiding pushing releases on a fixed date, or having any downtime when you need to deploy, spending hours on manual testing, for instance. So just some examples here. If you would like to dive a bit more into this, our director of cloud engineering, Alexander Lystad, he presented this on the DevOps meetup here in Oslo, measuring software delivery and performance to improve commercial outcomes. So I encourage you to Google that, and also you will be able to get the link afterwards. But let's focus a bit on the software testing and quality assurance. So first of all, I would say that context is everything. And this is basically one key thing for us in Visma as well. Because as you remember, we have like over 200 different services that are working on basically different ways. They are using different tech stacks. So in order to unite them to go on this cloud delivery model, we also cannot be too detailed on this. But just to give you some examples, if you were supposed to, for instance, test a pen, and then you write a test strategy for this and your test approach, you think about how you should test this, and then you basically get a pacemaker to test afterwards. That's sort of the next project. You probably won't just copy what you did already for sort of the pen and just to reapply it to testing the pacemaker. That will be really sort of not well documented or not well to do. And this is basically the same thing for us in Visma as well. We cannot sort of copy everything from each other, but also we see some approaches, but not only for Visma, but other teams that they go out there, they Google how to do test strategy, they find a plan, they copy paste it and just apply it to their sort of project. And that doesn't make sense because perhaps the plan that you copied is sort of testing a pen or testing a pacemaker, and your product actually is somewhere in between. So you could also you forget something or shave off some things if you're not following some regulations, for instance. But to give you just one example here that has been used in Visma previously is that since we are creating this accounting software, we also have this My Profile pages. And on My Profile pages, we have pictures of the people sort of using our services. From our point of view, we don't have actually too many tests verifying whether this picture is up and running or not. Perhaps some teams have just to see is the picture visible or not. But most of the teams don't care too much about that detail because that is not the core functionality of an accountant's system. But if we were to create a dating app or something else where the picture is really critical, we would probably reconsider that strategy. We would have a lot more tests and a lot more automation on that part. So this is basically, if the picture doesn't work in one way in the accounting services, not a big deal, we will survive. But if it doesn't work in the dating app, then you are in big trouble, and that's probably a critical issue. So just as an example there. Another thing that we are working a lot towards is to having this mindset of a test engineer. And basically, but just by using this fun example here, like if you were asked like how, this question here, when I was 4 years old, my sister was 2, I'm now 44, how old is my sister? And the usual answer would be around 42. And then Samuel Lipov here, copy paste from the net, he says, and this is a great mindset, like, this is a bit a tough one. Like, okay, she might be 42, she might be 41, she might be 43, but also like you don't know actually when her birthday is. That's the sort of reasoning behind that. But in the worst case, like, okay, she might be that. And perhaps you also thought that she was your sister, the one who is sort of alive, but you actually, mom, you had an affair with another man, and this is actually not your real sister. But it might be that your real sister, who you actually haven't never met, she was put out for adoption, and she's most likely older than you. And then again, you might think your sister is dead, but then she's basically a part of a secret government project traveling near light speed, which is basically making her age much slowly than you. So she might potentially be even younger than 41. This is, now you sort of see why this is a difficult question and not only straightforward. And this is give us a great sort of mindset of the tester. So for us in Visma, and I think most of you have seen this before, when it comes to continuous delivery, you have this loop that is going forever. But for us in Visma, for instance, we don't consider test as a phase, basically. inspired by Dan Ashby here, we are basically applying testing and quality assurance all over sort of this loop. So everything that has come to do with planning to it's out in production and beyond, basically. And what does this mean for us? So this means that we definitely needed to shift left, and we also needed to shift right. More in detail, that when shifting left, basically we wanted to start thinking about sort of testability and start thinking critically, and asking as much questions as possible sort of during this design phase, trying to figure out what are we trying to build here, and how is this going to affect our users, our customers? Are we introducing something that will not work? Let's try to experiment a bit. And how are we going to test this? Basically, is it testable at all? So think about testability and reveal some hidden assumptions as soon as possible. But this also means that when thinking about, for instance, automation, we also wanted to sort of reuse the test automation pyramid and try to imagine sort of, okay, where should we automate this? Should this be a part of a UI test? Should this be part of an API or service layer test or unit tests? And we'll dive a bit into that, at least how we are viewing the test automation pyramid. I know there is a lot of talks and controversies about that and discussions in the community in the world, but I'll give you at least our view on it. And of course, think about security as early as possible. And if something fails, we really need to have feedback immediately. So if one of the tests, automated tests, fail or something is not right, everything needs to stop. We need to figure out what it is, and then we need to move forward. And the same thing applies a bit to shifting right. So it means that when you actually have released your changes, so you deploy your changes throughout the environments and into production, what do you do then? Okay, we need to have some heartbeat checks. We need to see if everything is up and running. For some teams, this might be enough, so they don't care about anything else. They feel confident that they have tested what needs to be tested. These changes, again, just remember that these changes are small, so they are done continuously. For other teams, they might have some more smoke tests that they want to do in the production environment. So they want to actually log in to see if something is returning as they expected. But one important part here is as well that we are also utilizing a lot of monitoring in production environments, especially together with logs and different event trackers. So we know that when something or a change is made, basically both the usage in production, but also what kind of feedback that we get by, is anyone using this, what we have changed now, or perhaps if we are a bit uncertain, is this tested enough or not, perhaps we hide it behind a feature toggle, or if it's not probably like completely done yet. And then we can enable it for some users, get their feedback, we can experiment quite quickly, and then we get the feedback that we need, and then we sort of redo all of this. And this leads us to basically our continuous testing strategy, which is basically, we want quick feedback. We need to automate where it makes sense to automate, not only the tests, but sort of everything around as well. Where it makes sense, of course, you use the test automation pyramid, or in some cases the diamond, as you will see. And also we want to avoid manual regression testing or manual regression checking. So that these tests that are repeated over and over and over again, those need to be automated. Otherwise, you will not be able to release frequently, because this will be one of the parts that will slow you always down. And we definitely want to utilize as much exploratory testing as possible, as we will see. And non-functional testing being basically one of the, perhaps if not equally important, even more important than the functional testing as well. And back a bit to the whole team approach, this service delivery team mindset, we know that one tester or one set of testers are not the ones that can verify the quality and do all the testing themselves. This needs to be spread out throughout the whole team, and everyone needs to be sort of involved in actually making this product great, and also contribute to testing and quality assurance efforts. So if you go just in as an example through how a typical delivery pipeline would look like, giving some quick feedback as well from like a regular team in Visma, it all starts sort of with an idea. It might be an idea from any of the developers or anyone in the team. It might be from the user. It might be generated by a bug or a feature request or something that the competitors have that we don't. So there's a number of ways where sort of an idea or a change request might come from. And then we start sort of designing it, just starting to think about, okay, what are we actually going to do here? Do we have enough data? Perhaps we go out and ask the customers, is this what you wanted? Perhaps on the sort of lo-fi prototypes. So we are not coding anything yet. We're just gathering enough information so that we can say like, okay, now we have enough information. Are we still going to make this or not? And if we decide to, yes, let's do this, then we start us, of course, the implementation phase. And here in the implementation phase, we can also collaborate with the developers, with the testers or test engineers and other roles, basically. And then when we feel that, okay, now we have something that we can basically push to the next stage, the code is, of course, checked, it's reviewed, and it's, of course, merged to master or directly in master as well, depending on the branching strategies that the team has. And when this is done, when this quality pipeline is done, it's basically pushed into master, and then the delivery pipeline, which is fully automated in some cases, is triggered. And this means that the build is sent to the continuous integration servers, the tests are run there, and then the first environment, which is internal in our case, is provisioned, configured, and the changes are deployed there. And after being deployed, it's of course checked whether everything is working, and some of the tests are starting there. And in our case, the internal environment is basically an environment which is isolated or encapsulated for the entire team itself. So this might, like every integration that you might have is basically mocked or stubbed. And then sort of that there is no other teams that can affect your internal environment. And this we wanted to have in place because we wanted to check the changes that we are doing as soon as possible and test them without any sort of interruptions from other teams, as we have experienced before in some common test environments, which were perhaps poorly maintained and a lot of mistakes were made, which slowed everyone down. And then, of course, this change is promoted to the next environment, in our case, a pre-production environment called stage. Again, the same procedure. We run some more integrated tests because in this environment, you will meet basically all the other services that you integrate towards live. And then you can test some integrations if that is what you like before promoting it to production. And after it's promoted in production, we basically learn from, okay, what is happening in production right now. And this goes back basically into the loop and feed basically the next thing that we will do. Was this a bad choice? Was this a bad implementation? If so, basically we needed to fix something, and then this loop goes on and on. And I'm not sure actually if you see this arrow here, but it says it should take minutes, hours, or days to complete this. So this feedback loop here is really quick, even though it contains a lot of elements. But again, this depends on from team to team, like how quickly they are able to do these changes. But we aim to have it as short as possible. And then when it comes to automation, of course, this is something that we are investing a lot in. And as mentioned, we try to use the test automation pyramid as sort of our guidance, but we are not religiously using it or following it. So it doesn't need to look like this for all teams. What we want to actually do with this, or our goal with this, is to actually illustrate that there are different levels of granularity that you can write your tests. Some tests you can write more in isolation. They can be much quicker to run. Other tests you need to have more components in place in order to run, such as UI tests or API tests. And of course, they will run slower as far away that you move from the code. And also, like as far up you come to the pyramid, the fewer tests you should have. So everything that you can check or test in these lower layers, you should of course do that. And also we try to sort of push the test that we have. Some teams, of course, have perhaps a bit UI heavy pyramid, but then we discuss, okay, perhaps some of these tests should be moved to the API layer or the service test layer. And basically every team needs to look into this test automation pyramid, make sense of it, and sort of start working with it. But we also wanted to point out that even though you automate a lot, it also is very sensible to remove the tests that don't provide any value. So if you have a test that is always flaky, that is always sort of slowing you down, taking away your time from like being productive and doing stuff, then of course you should remove that test. And in some cases, actually, where we have microservices, it makes much more sense actually to have a much sort of wider service test layer than this unit test layer, because the small microservices that the teams are creating, they do make sense to test in isolation in some sense, but it's much more important that it works in a sort of a microservice architecture way. So we know that sort of integrating towards other services is much more important, and that is the only way that this microservice can be used. So why not spend even more time on creating the service layer tests rather than pushing everything down to the unit layer, which will give some restricted value. Then when it comes to exploratory testing, we all know that it's really nice that we have this sort of safety net of automated tests. But as we also know that we never know sort of the full extent of our service. We're always learning how the service is working. We're always learning new things, and also when we are adding new sort of changes, the scope of our service is also ever expanding. So we will never have sort of full test coverage here, and we will have a lot of holes in our test automation. That is why exploratory testing is extremely important to have, and that everyone sort of doing is sort of trying to sort of emphasize this part of continuously learning and have this rapid cycle of learning, and applying this knowledge to perhaps focus a bit more on certain part of your services, or actually also learn about these different holes, and perhaps we should basically cover them up with some automated tests. But again, when it comes to automation, we try to automate where it makes sense, and we are not sort of just throwing test automation cases at it just to have a large number of them. Where it makes sense, it's automated. Where it makes sense to perhaps test it manually sometimes, perhaps we just do it once and then don't think of it again, depending on the risk and of course what we want to achieve there. Then on the non-functional testing, we are focusing on three basically major areas, and I won't dive a bit into them too deeply because I want to have some time for questions later on. But just to highlight some parts that we are doing, like the performance testing. One thing that we have changed there is basically we don't consider performance testing to be necessarily basically valid to validate or verify the load or the performance, because the load testing or stress testing that you do is basically very limited. And if you are doing continuous delivery, it's much more sensible, or it makes much more sense to have good monitoring. So when you do actually make a change, that monitoring can sort of and alerting can catch performance issues as quickly as possible. So you don't need to sort of spin up new environments, run some load tests, because you can actually generate that load live basically in production. But of course, we do use the load and stress testing if there is sort of a peak that we need to shave off, or if the service is basically used once a month and suddenly hundreds of thousands of people log in to check their salaries or their pay slips. Of course, in some of those cases, we just want to simulate, okay, what happens if 200,000 people logs in and start using our service. So in some cases we are using it, but we are also relying much more on monitoring and also predict sort of the usage, traffic and patterns, etc. When it comes to reliability, we try to also be aware of our own recovery objectives and try to be prepared when they hit basically, and when they sort of, we know that they will happen in production. And if we are prepared and if we have trained or simulated some of them, it's much easier sort of to act upon them when they actually happen in production. So this is something that we are continuously doing throughout the year, trying to turn off different components within our services, between services, etc., to try to figure out if we have some single points of failure and improve them, and also sort of drill for our service that we know that, okay, when this happens, this is actually what is going to happen as a response. It might be automated, but it also might be basically some manual recovery that we need to do. And the last part, security, perhaps one of the most important things these days. We basically treat this as anything else that we do. We have shifted both left and right when it comes to security, like scanning all the code with static code analysis tools, or both for own vulnerabilities and also vulnerabilities for third party, different security audits and penetration testing, both using internal and external experts. So there's a lot of work being done both within the team when it comes to security, but also we have some security experts who are sitting outside the team that might sort of come in and help the teams when needed. And then we have the testing in production. And here I usually see that there are sort of two camps here, like you just don't test in production. That's sort of almost like cursing in the church, so to say. But then on the other hand, there are some people that, yeah, like I don't test my code, but when I do it sort of in production. So in Visma, basically, we are a bit sort of somewhere in between here, I would say. If you think about it, like the production is actually the only environment where things need to work. The customers or the users, they don't care if this worked in staging or in internal or in acceptance or in dev or whatever the environments are called. If it doesn't work in production, okay, what kind of value have you given the users? Doesn't matter. So we think that, of course, there is a value to test in production for some of the tests, but it's not okay, of course, to test in production if you haven't tested anything before the change hits to production, of course. It might be in some cases that you do some light testing and you hide it behind the feature toggle, depending on the risk that you are doing and the change that you're doing. But again, you definitely need to do some testing and some verification in production as well, and not only sort of in the previous environments. And these are just some fun examples of things where basically testing has been probably done on a, let's say, unit and integration layer, perhaps a UI layer as well. And it worked in isolation. But of course, when you are trying it out in production environment or real environments, basically you can see that there are some flaws with these approaches, just to illustrate that. And then we come to the last point. What about the future? So basically, we know that the software is eating the world. This was coined by Martin Dresden many years ago. And I think this is just very obvious that has become true the last years. But the latest thing as well is that AI and data will also eat software. So we think that basically the AI and machine learning and the data that we have sort of vast amounts of data that we can utilize to create good algorithms that can help us in different ways. And these parts, the AI machine learning algorithms and the data, they will basically power the software engineering. So we're also trying to look into how this can help our development going forward. And we have seen some, of course, examples from Facebook using this Sapien, Sapfix, GetTheFix, and also these predictive test selection techniques, for instance, or some other tools where you can automate some or generate some tests as well. GitHub came out with Copilot not that long ago. Of course, these are still very early on phases, basically, and that's why this grain of salt is in the bottom left corner here. The salt is not visible, I think, but it of course it gives us some let's say prediction of what will happen in the future, and even though they are very, very young or very early on, not very mature in some cases, we see, of course, the need, or when they are going to develop, we see that they will basically enhance a lot of the things that we have. For instance, we will get even quicker feedback. Perhaps it can choose for us what kind of test should be automated based upon which test will fail going forward. The same thing when it comes to exploratory testing. Just imagine like you are doing some exploratory testing, but on the side you get all sort of different KPIs and metrics and insights that probably is sort of generated based upon how the users are using this in production, just as an example, etc. So this is basically what we see the future will be. But I also want to highlight that I think context still matters. So no matter where we are going to end up in some years, I think it will always be really important to think about the context. And also as a sort of takeaway from this presentation for you listening in today and watching this, think about basically how this can be applied in your context. So don't just blindly copy how things are done, but think about how can we do this. So to summarize, what led basically to our changes and how we changed sort of the way of working is basically that we want to be part of this acceleration. We want to be able to change quickly, and we want to be able to learn and adapt when that's needed. We also are using the public cloud, continuous delivery, and DevOps principles as our core principles for driving the software delivery forward. The data and research that has been backing up our initial assumptions, both our own data that we have gathered throughout the years, but also from Accelerate, State of DevOps Reports, and McKinsey and Company. And the way that we are doing sort of continuous testing, getting quick feedback as soon as something happens, we know about it, everything stops, we fix it, utilizing the automation and pyramid and diamonds, and basically as the guidance for our automation efforts. Exploratory testing still really critical and valuable to learn from, and also the non-functional testing and whole team approach. And the last part that we just went through, basically that the machine learning algorithms and the data, which will basically power the software engineering going forward. So with that, which is my last slide, I want to thank you for listening. And I see there are a number of questions here. I'm not sure, Praveen, if you are going to go through them, pick out someone, or yeah.
Hey, Mili, yes, let's do that.
Yes.
Let me, if you could stop your screen share, and I'll just start mine again.
Oh, yes, let me see. Like this.
Yep, awesome. Thank you. All right. Yes, we have a lot of questions. So let's try to go through them quickly. Awesome. Okay, one question from Neil. How long did it take? How long did the whole shift right sort of implementation take? And you talked about different KPIs and tracking and measuring different KPIs. Which one was the most important one for you or for the team in terms of getting continuous testing / shift right implemented?
How long did it take? Yeah, it's a bit different from team to team, because I can also mention that today we have around 70-75 teams working this way in Visma. So the rest of the teams have sort of not onboarded this way of working. They probably do have some elements of it. And the way that we are driving this change forward is through, for instance, some assessments that we have created. So we have created an assessment for how you should do continuous delivery, how you should do technical depth management, public cloud architecture, etc. So we have a number of different assessments that the team takes. And it depends a bit sort of on the team, where they are and what kind of maturity they have when it comes to how long it will take. I know there are some teams that have used some months just to make the shift, but they were sort of already doing a lot of these things. They just re-verified themselves basically through this, but other teams use much longer time than this. So it depends a bit on the team how long it takes. I unfortunately don't have a good answer, like
Sure.
to just say 6 months or something.
Sure. Fair enough. Okay, so we spoke about shifting right. Question on shifting left. So the question is, is there a recommended branching strategy which can make it easy to shift left? The person's asking, I think testing on a feature branch can be more effective than testing on a dev branch, for example. Can you recommend a best fit strategy?
No, I cannot. We actually allow all different branching strategies that make sense for the team. Some teams want to use this feature branching strategy and then sort of merge into main. Some do everything sort of in main directly. And we have done some research or just some like questionnaires with different teams, try to figure out what works best for them. But we don't have actually a conclusive sort of report there that says like, this is the best branching strategy that you should use. So the data that we have collected there from the teams, they don't point in any direction, but if you, for instance, are using the feature branching strategies, your feature branches should be short-lived as possible in order to sort of be able to integrate a lot, to be able to change quickly, etc., and also not get hung up on different branches and sort of forget what you were doing.
Awesome. Okay. All right. A bit of an ambiguous question, but it's I think Matt is asking. You seem to have put in place processes or systems which are very free flowing and flexible. How do you what rules or structure do you have to guide your dev teams?
Yes, we do this through these assessments, as mentioned. So, for instance, in the continuous delivery assessment that we have some requirements that when you deploy code, you should deploy with 0 downtime. If you want to achieve, of course, continuous delivery, you cannot sort of plan to do this every Saturday evening when none of the customers are logged in, and you need to take everything down and then do a change and then bring everything up. So we do have in these, as part of these assessments, for instance, in this continuous delivery assessment, we do have that you need to write unit tests on a certain level that we don't have any sort of code coverage percentages or anything, but what makes sense for you, you need to think about, do you have a good code coverage or not? But we also have some of these requirements that you need to promote your changes throughout the environments and not sort of build and deploy to individual environments. These are just some of the requirements, but we have, let's say, probably 20-25 different sort of capabilities that we have as part of this continuous delivery assessment that we have. And these capabilities are guiding the teams in the right direction. Can you deploy code without your customers being affected today, right now, 12 o'clock, peak time? If you can do that, then we know that you have 0 downtime availability. That's a sort of one capability that we have.
Got it.
And all of these different assessments have different requirements if you want to sort of move in the right direction. Yeah.
Got it. Okay. So Mili, I think in one of your slides, you've spoken about identifying flaky tests which are slowing down deployment, right? Slowing down testing and ultimately deploying. And you said you should identify those and remove them. How do you assess? The question is, how do you assess the risk of, or do you assess the risk of removing the flaky automated test case, right? Prior to removing it, how do you know that it's safe, in quotes, to remove it?
Yeah. Well, I would say we don't have a formal process for that. It's more of a gut feeling. But of course, let's imagine that you have a test that is, you run your test automation test suite, and you know that test always fails. What kind of value is it giving you that it's failing or passing? Because if it passed, okay, it passed, great. But then if it failed, you know that I just need to rerun it once more, and it will probably pass. And if it passes, everything is good. Then you have sort of wasted a lot of time actually just there, and you don't trust this test. So I think sort of the value here is that, okay, why should you, if the test doesn't do what it's supposed to do, and it doesn't provide you sort of a yes, no answer, then you should remove it, because you cannot trust these tests. And if this happens a lot within a lot of tests that you have, the entire team will lose trust and confidence in your automated test suite. And then you will be at the point where everything failed, but let's just rerun it a couple of more times until everything passes. And of course, after the third time, if things fail again, then we will look into it. Then you have lost and wasted a lot of time for everyone, basically, by doing it like that. You should rather take those tests. Does it work? Does it not work? If you can fix it and put it back in, so you have the trust and confidence. If it doesn't work and it's still flaky, okay, perhaps you need to rewrite it, refactor it, do something with it, perhaps even delete it.
Got it. Okay. Quick one, I think before we move to the next question, the team's going to be popping up another poll or question for you, for all of you to answer. If you'd like somebody from Browserstack to get in touch with you, just feel free to sort of say yes, and we'll get in touch with you as soon as we can.
And I can also mention that we are also using Browserstack in Visma for our cross-browser testing, and also for live testing, because for us, it's much easier sort of to have like a cloud environment where we have all the devices, all the different combination of real devices, mobile devices, or Mac OSs on different versions with this and this flavor of browsers. So I would definitely recommend you to use this if you can. And yeah, rather than sort of, we have tried to maintain this ourselves, it doesn't work. The world is changing too much.
Yeah. I mean, definitely, I think the number of browsers and devices, or at least devices being launched every year is insane. It's growing exponentially.
Yeah, exactly. Yes.
Yeah. All right. I think we have time for maybe one last question, Mili. I think, can you talk about some of the headwinds you faced or the team faced in implementing the service and UI tests in staging and production? And also, if you could tell us a little bit about selecting the right frameworks and tooling, as you go through this journey.
The first one was on the testing
headwinds
UI challenges?
Yeah. Service and UI tests on staging and production.
Yes. So I think like the challenges have been, of course, like where to start, how to get started, and also a bit sort of on the second question, what kind of tooling should you use? Those are sort of universal questions. And when Visma acquires a company and we sort of integrate them into the Visma family, that is like one of the first questions: what kind of tooling are you using for automating this and that? We are very sort of tool agnostic, so we don't like, you can use whatever tool you want, what makes sense. But when it comes to tooling in sort of, let's say, UI testing or API testing, of course, you should use something that the entire team is familiar with. So if you are tasked as a test engineer to figure this out, you should look into what kind of tech stack the rest of the developers are on. So let's say you are working on Java, then probably you shouldn't sort of choose some kind of C# related tool, but you should choose something that the developers also know, because they will help you to implement a better framework. They will also help you with some sort of better coding and better setup and structure of the tests as well. And this will sort of benefit the team in the end. When it comes to the challenges, there's been, I guess, several challenges, but like just changing sort of the mindset that everyone needs to be involved, I think, has been one of the challenges, and we are sort of still struggling with that as well. This separation of who should write which tests on which layer is also sort of an ever sort of going challenge that we have. So I'm not sure if I know about sort of one specific challenge that we have had that has been sort of universal for all teams, but I would say just start small. Do like a set of smoke tests that you know that you need to have running basically all the time, and just start there and just improve from there. That would be sort of my advice, at least on the API and the UI tests.
Got it.
And awesome. Of course, you mentioned to test the data as well, to have everything sort of isolated, so each test can run on itself.
On its own, right.
I also just I will try to take all the questions that are not answered. I'll try to copy them, and I'll see if I can find some time to answer all of them. So perhaps if you join the Slack channel that we have in Browserstack, we can address them there, or
what we'll do, Mili, we have a copy of all the questions, so we'll share them with you. I think it'd be great if you could find some time over the next few days to answer as many of those as possible, and then we can actually share it via a blog post with the entire audience. That'd be great. Awesome. But thank you, Mili. Thanks a lot. I think it was a very, very insightful session. I think just going by the number of questions people had, I think a lot of people really enjoyed the presentation. My favorite slide was the Mandalorian, this is the way slide. I'm a big Star Wars fan. So
that's nice.
but no, more seriously, I think it was interesting to see both the shift left and shift right approach, and very, very admirable what you've been able to accomplish at Bisma. So thank you for walking us through that journey. And thank you all for taking the time to attend. I think we will be sharing the recording, and Mili's promised to answer as many of these questions as possible. So we'll share that via blog post on our blog. Awesome, great. I think we'll end there. Thank you again, Mili.
Thank you all.
And folks, as we leave the webinar, you will get a quick question on just feedback about the session, about the webinar. So just take a minute. It'll take you 30 seconds to just fill out that poll. So let us know how you think the webinar went. It'll help us do it better the next time around. So thank you all for taking the time to attend, and thank you, Mili. Have a great day, everyone. Thank you.
Thank you. Have a great day, evening.